Hi, I'm Tianxu Li from Carnegie Mellon University. Today, I'm happy to present our paper, Understanding Challenges for Developers to Create Accurate Privacy Nutrition Labels, on behalf of my co-authors, Kayla Raymond, Yuvraj Agarwal, Laurie Craner, and Jason Hong. Privacy policies offer limited benefits to users. To address this issue, researchers propose privacy nutrition label to offer users a clear, uniform, and brief summary of how their data is collected, used, and shared. After a decade, this concept has made its way from the research labs into the two major mobile app stores. Apple required all apps to provide a privacy nutrition label since December 2020, and Google announced a similar requirement coming in early 2022. Privacy labels are self-reported by developers. If the privacy labels are not accurate, they will probably do more harm than good to users. However, we currently have little understanding of developers' ability to create accurate privacy nutrition labels. In this work, we want to present the first study of the privacy label creation process from the developers' perspectives. Our study is focused on the Apple privacy label, but our insights will also help other app stores and standardize privacy notices in general. We want to answer three research questions. First, what are developers' perceptions about privacy labels? Second, what types of errors or misunderstandings do developers exhibit when creating privacy labels? Third, what challenges do developers face in filling out forms to create privacy labels accurately and efficiently? We had a very diverse sample, with developers coming from different countries, develop apps of different sizes for different purposes, and also served in different roles. By the time we conducted the studies, this requirement has been launched on the App Store for more than 8 months, so some of our participants already had some experience in creating a privacy label for their apps, and some apps already had a privacy label. The first part of the study was completely observational. Participants were asked to use a replica of Apple's developer tool to create a privacy label for one of their own apps. The process of creating a privacy label using Apple's tool is like filling out a questionnaire. First, the developers need to answer one question. Did you or your third-party partners collect data from this app? Only if the answer is yes will they be taken to the second step, where they will select all the data types that were collected by their apps. Finally, they need to provide further details, including the data collection purposes, whether the data is linked to the users, and whether it is used to track users. The second part of the study is a semi-structured interview. We asked our participants questions about their app's data practices and their thinking process, so we could prompt them to check their answers when potential errors arose. The recreated privacy label was also compared with the current privacy label on the App Store if one exists. Now I'll present our key findings. In response to the first research question, we found that the general reactions of our participants were pretty positive, and it's really encouraging that some developers found the side effects of forcing them to think more about privacy as a positive thing. However, a lot of errors and misunderstandings were still prevalent. 9 out of the 12 developers made errors and were not able to correct them unless prompted by the interviewer. And among the 8 apps that already had a privacy label, 6 of them were created inconsistently. So what are the errors? We summarized 8 types of recurring errors and misunderstanding in this table. The first surprising finding is not only underreporting was common, overreporting of data practices was also a common issue. For example, Apple's definition of tracking has 2 criteria. First, the data is linked with third-party data. Second, the data is used for targeted advertising-related purposes. We found almost all developers got this definition wrong and reported cases that should not count as tracking by Apple's definition. Next, I'll present a deep dive into the 3 types of challenges that potentially caused the errors that were identified. Unknown unknown is the first category of challenges, which refer to situations when developers don't realize that they don't know something. One main problem is developers relied on preconceptions that differed a lot from Apple's definition. For example, when seeing the word tracking, developers often immediately think of location tracking, user behavior tracking, and bug tracking, while none of them is mentioned in the definition. Furthermore, misunderstandings were still prevalent even after we requested developers to read the definitions. We also found knowledge blind spots related to the procedure of creating privacy nutrition labels and the resources that support this task. Our study showed that although many widely used libraries have provided guidance for this task, developers were unaware of their existence. The second type of challenges, known unknowns, refer to situations where developers were unsure about their own understanding. Developers frequently refer to hard-to-understand jargons and concepts unfamiliar to people out of the US. Furthermore, for developers employed by a large company or develop apps for a client, they may only understand part of the life cycle of data collected by their app and do not have sufficient written documentation to fill in the knowledge gap. The complexities of the task make up the last category of challenge. There are 4 subcategories, and I want to talk about 2 of them. First, developers complained that they needed to read a lot of text. This information load could have further implications than simply increasing the time spent on this task. For example, P1 admitted that they may not always update their privacy labels in a timely manner because upgrading it or at least reviewing it on every update would be tiresome. Second, many apps selected for this study were cross-platform apps. Although Apple and Google used similar concepts or even the same term, their definitions differ substantially from each other, which may lead to errors and confusions. Our work demonstrated a dilemma. On the one hand, we want to leverage developers' knowledge about their own apps to provide a thorough disclosure of data practices. On the other hand, they know little about privacy and have little time to deal with privacy requirements, which resulted in inaccurate privacy nutrition labels. Therefore, we want to call for more developer-centered research to unleash the synergy between developers' knowledge and better tooling support. For example, we as privacy researchers should design developer tooling to automate the privacy label creation process and iteratively evaluate and improve the design to serve a wider range of developers with different development goals. To sum up, we present the first study examining the privacy label creation process from developers' perspectives. We found that although developers generally felt positive about privacy nutrition labels, developers' misunderstanding of key terms, limited knowledge about available support, and the complexities of the task make it very difficult to create an accurate privacy nutrition label. We argue that achieving widespread adoption of standardized privacy notices requires better support for developers, including better design and evaluation of developer tooling and cross-platform support. Thanks for watching, and I'm happy to take any questions.